Hey guys, so I already broke my rule of posting option video on Thursday. I guess it's Friday morning, but the market went a little bit against me yesterday, so I had to make sure everything was okay. So, anyways, in this video, I'm going to be talking about QuantLib and give you guys an introduction to QuantLib. So, QuantLib is like a super duper package for anything in quantitative finance. Like it has the most sophisticated options pricing models, all the ones you read in like academic journals. So it has things like the Black-Scholes model, and then gets more complicated tree methods, finite difference methods, Monte Carlo methods, stochastic volatility methods, jump methods, all these other things. There's exotic options. You can calculate Greeks, that sort of thing. You can model volatility smells and surfaces and interest rate term structures, like what it really is, dividend term structures. And you have all these risk management metrics that you can get. It's a really good library. It has a big learning curve. So that's why I want to start like with the most basic example. But I think it's worth it in the long run because you don't want to just rely on interactive brokers for like your whole option pricing and stuff. And also there's stuff that the interactive brokers option pricing can't do. So it's good to have it's good to have a backup source for that. Okay, so anyways, by the way, it's written in C++ and it has like all these Python bindings, a lot of documentation. There's this QuantLib thing. This is the site. But also if you Google QuantLib Python example, sorry, I forgot this thing. There's a guy, this guy, he has some really good examples. He has very good examples. So let me add this here. Okay, so let's get started. And of course, later videos I'll compare this to interactive brokers and that sort of thing. Okay, let's get started. And so first of all, for people who don't know, of course, a vanilla European call option gives the owner a right to buy the stock at a certain price called the strike price at the expiry date or maturity date. That's a European call option. A put option gives the user the right to sell the option at the expiry date. So that's a vanilla European option. I shouldn't call it user. It's like holder is the name. Okay. So let's first do the Black-Scholes formula with ChatGPT. So you put ChatGPT, you kind of tell them to fix the formats, and it gives you the Black-Scholes formula here for call option, for put option. As you see, the interest rates in the formula, you'll see they come up. R comes here, and R comes in this D1 term. This is like a cumulative normal distribution. So you get the interest rate, you get the volatility or standard deviation is sigma squared, sigma, and you get those are all constant in this example. Same with the dividend yield here. It's a continuous constant as the assumption. So anyways, these are the formulas that assumes a lot of things like efficient markets are efficient, no arbitrage, you can hedge everything perfectly. But in real life, a lot of times you can't hedge everything, like jumps. But anyways, I don't want to get into too many details. I just want to say let's use this as a baseline to compare with the QuantLib version. So, okay, so manually, this is the manual ChatGPT version. We can calculate the option price. We can. This is just if you go to ChatGPT, ask them to give you a function for call and put options. They'll give you some function, and you copy and paste. So I made a function of option type, calculation date, expiration date, current stock price, strike price, volatility, risk-free rate, and dividend rate. And okay, so a few things to know. Time to maturity in these things is usually quoted in a year in Black-Scholes formula. And this 365 is like a year, and I'll get into why that's important in a bit. Yeah, so all I said is the inputs are the calculation date we want to calculate. Expiration date is this expiration date in this format, like year, month, date, and then we'll get the price. By the way, in this example, everything is the day level. And let's assume a day level means end of day. Like let's say option expiration is like end of Friday, and one day before is end of Thursday. Anyways, okay, so if we were to get this option price, we can of course do we can plug it in. Oops, what did I mess up on? Oh, sorry. Let's say you do option type call, calculation date, expiration date, current stock price, strike price, volatility, risk-free rate, dividend rate. You plug it into this get BS price ChatGPT. You get that. I'm just showing you an example below, switching call with put. In the option type, you get 6.88. And in the future videos, I'll try to like set these to the variable names. For some reason, it's not working. I have to figure out why. Okay, so now let's do the QuantLib. What's important? Okay, so let's import QuantLib, and let's talk about like what we need with a QuantLib model for option pricing and specifically for Black-Scholes. So because QuantLib gives you the opportunity for the risk-free rate not to be constant, to have a term structure, which is much more realistic to real life. It allows volatility to have a surface, to not be constant. As we know, volatility is definitely not constant, and it is stochastic and random. There's also dividend types, like, and that sort of thing. It's much more general. So let's go through the requirements a bit, and then we'll show you one by one how to set them. So first thing is you need the option type, call or put. You need the maturity or the expiration date. You need the calculation date is when you want to calculate the price of the option on. So like let's say the calculation date can be today for expiry in 3 weeks from now. Strike price is the price you willing to buy for a call, sell for a put. Yeah, it's just a number. Option payoff, as we said, we're talking vanilla usually, which is the right to buy and sell. There are more exotic options with non-vanilla payoffs, but we're only concerned about vanilla. But like this library is so general that it allows you to do way more things. Spot price is just the current stock price. And here you'll see that it's so general, you could even have like current forward price and a lot of other things, but we're only going to talk about spot price. Okay, so there's another interesting thing called day count that you need to know. So this tells you how we're planning on modeling things. So like basically for interest rates, they accrue every day, right? So that's why it could be 365 makes sense. But there's some places where they actually accrue it like on a 360-day level. So basically, like let's say let's say for borrowing interest, I have like a fee, like a percent per year, and I will divide that per 360 to get the day amount, even though there's 365 days. It depends on what convention there is. Also, some things are business day accrued, but like interest rates are usually 365 or 360 day accrued. Okay. And there's another thing to add to the generality is a calendar. So this gives you like specific business days around world exchanges. So basically, I guess maybe a good example is the U.S. has certain business days, and let's say Hong Kong has different business days. So that's important to know. So this library is just so general. You can do anything. So we're showing you the most specific example with everything constant, but we're showing you the general thing. By the way, also like sometimes it makes sense where in like let's say the Black-Scholes formula, the risk-free rate, the compounding is daily, so 365, but the volatility would be like business day wise, because let's say the stock price isn't as volatile between Friday and Monday as between Monday and Thursday. Usually it's on a per maybe it's more accurate on a per business day level for the volatility, but on a per a calendar day level for risk free. Okay, so I just want to say, of course, it's very general. You can have term structures for risk free rate and dividend, and I'll show you how to do that in a second. Same for volatility. Let me write it for volatility. Okay, so we'll fill in all these blanks now. Okay, and to add to the generality, there's like geometric Brownian motion. OU is a mean reverting process. Black-Scholes process. So you have all these stochastic processes that you have to mention in your formula. And there's exercise type, European, American, Asian, and then there's a pricing engine. So there's binomial tree, finite differences, Monte Carlo, so on. We're gonna use We're gonna use the analytical Black-Scholes one. Sorry, my mom's talking in the background. Anyway, so we're gonna use the analytical Black-Scholes one. Okay. But in general, these are so general. You have like the binary, finite difference, Monte Carlo, and so on, for things that you don't have an analytical solution. But for European call and put, you do with the constant assumptions and that sort of thing. And then you finally call the net present value method to get the value of the option. Sorry, I lost my train of thought because my mom was yelling. Anyways, okay, so let's get started. Let's go step by step on every single one of these, and then we'll just create the function. Again, this has a huge learning curve. So like, if we do a few examples, like we'll start getting the hang of it. So okay, so option type. We have to define the option type. So I wrote option type equals QL dot call. There's call and put. So call and put, and you see it gives it a value of 1 and -1. So now we have to do maturity or expiration date. So like I'm gonna show you in two different ways. One is you could write it as a string like this, and you could use this QL.date parser .parse ISO, and then you get a maturity date like this. Or you can directly do QL.date like this. Okay, so now we need a calculation date, right? This is the date we want to calculate the option on. So we could have the calculation date, we can use the parser, and then we get the date like this. Strike price is the strike price we want to use. So let's use, let's say strike price equals 120. The payoff, we said we wanted vanilla payoff. So we'll do payoff equals QL.vanilla payoff. Option type, that was like the call and the strike price. So this gives us the payoff function. Spot price is just the current stock price. So you can do like, you could write spot price equals 100. And now this is where it gets interesting, is like, because this is so general, sometimes you don't have just the current price, so you could use like a forward price. Let's forget about that. Just know that it's so general that you don't just write spot price. You have to do QL.quote handle, and then you put in a simple quote, QL.simple quote, spot price. That gives you like the spot price. This is all this is just saying current stock price 100. No fancy other things. Okay, as we mentioned before, the day count thing. So you can have, I said the 365 is like QL.actual 365. That's one example of day count. You can also have the day count business, as I said, QL.business 252. And then let me see if I have this example. Day count 360. I can do QL dot, I think it's called, you know what, there's a thing, let me say day count in QuantLib. There's many examples, I think. Sorry, I lost my train of thought. Um, had an example of this. There's a maybe I'll do this. Day count 360 quant. Day count, maybe this. There we go. So there's okay. So actual 360. So these are example of some day counters they have. You should read more of the documentation, but like let me just write this here. This thing. Okay. So this is a day counter. Okay. So this is kind of if you want to accrue on a daily basis, a business day level, that sort of thing. Okay, so we don't need this. Calendar, like I said, like it deals with holidays around the world. So we can use like the US calendar, but there's like, if you see in the documentation, there's calendars for all over the world. Maybe I'll just do QuantLib calendars. It'll show you like there's calendars for like a ton of places. Whoever has a stock market. But like for most of you guys, like even abroad, I'm kind of guessing that you trade the U.S. stock market. Okay, so like we said that QuantLib is very general with risk-free rate and dividends. You can have like a term structure or a fancy thing or stochastic or whatever. But just to show you, like for dividend rate, you can just give it, if you just want like a constant, you'll just give the dividend rate and you'll do QL.yield term structure because it's so general. You have to write the general stuff. And then if you just want the constant one, the simple constant one, you do QL.flat forward, calculation date, dividend rate, day count. And you have to give it that because it'll translate it to the right stuff. But it's always this format: calculation date, dividend date, and day count. So very similar for the risk-free rate. You're gonna have like the term structure, and then if you just want the constant one, you'll just do a QL. You'll do the flat forward, calculation date, risk-free rate, day count. Very similar. So funny how much work we're doing for very simple things, but in the future when we want like to be super general, this will really help us. Okay, and the Black-Scholes model assumes constant volatility. So of course we are going to do constant volatility for now. But in the future we're going to do other videos on like volatility surfaces and stuff. We will show in other videos volatility surfaces and stochastic volatility and jumps and so on. So we're gonna in other videos make this much more much more accurate in general. But for now we're just gonna use QL.black vol term structure handle. That's like the general thing for volatility. And here is where you'd write like a surface or whatever. But just for constant volatility, constant like in Black-Scholes, you do QL.black constant vol, calculation date, calendar, volatility, day count. Here you'd need calendar for a reason that you don't trade during there's no trading during business days. So I guess it wants that, wants to know that because the volatility wouldn't be the same if there's days off as if there's no days off. So it's very similar to this flat forward, except you have to have a calculation date and calendar, volatility, and day count, and it's called black constant vol. So it's very similar. It's hard, I mean, because it's so general. Okay, so now to add to the generality, you have to give the underlying stochastic process. So it could be geometric rounding motion, OU process, that's mean reverting, Black-Scholes, all that good stuff. Pain in the ass that it's so general, but we're of course for options using the Black-Scholes Burton process. So let me show you guys how that's done. So you give it Black-Scholes Burton process. This gives you the initial starting price. You have the dividend term structure, the risk-free rate term structure, and the volatility term structure, like that. Um, and I didn't click here. So that's the Black-Scholes-Merton process. And then you have to give it an exercise type, like European, Asian, that sort of thing. So like first you would do like you'll give the exercise. It's like EU exercise, QO that European exercise, a maturity date, and then you do European option. Equals QO that vanilla option, payoff EU exercise. And now, okay, now we need to give the pricing engine. So there's many options. You can do binomial tree, finite differences, Monte Carlo, and so on. But since for European option, with all the volatility, risk-free rate, all that stuff constant, you can of course get an analytical solution. And the analytical solution would be like this. European option that set pricing, QL the analytical European engine BSM process. Of course, in the future, we'll show definitely this finite differences and probably binomial tree because we want to deal with more American options and non-constant volatility and that sort of thing. And you don't have an exact formula for that, so you really need to use one of these approximation methods. Okay, so you set the pricing engine, and then to get the actual price, you do this like dot net present value. It probably won't work because I listed everything. Oh, it did work. Okay, so yeah, that's a very complicated way just to do Black-Scholes formula, but in the future it'll really help us once we have non-constant volatility and that sort of thing. So I just wrapped this in a function like to calculate just the Black-Scholes formula to calculate BS price with QuantLib. So it's going to have the exact arguments as the ChatGPT version above. Option type, calculation date, expiration date, current stock price, strike price, volatility, risk-free rate, all that good stuff. You're going to choose a calendar, like a day count, calendar, option type. Maturity date is when it expires. Calculation date is when you make the calculations. Payoff, we want the vanilla, the normal one. We define the spot handle. That's the current stock price, as we mentioned before. All the risk-free rate, dividend, and volatility term structures. So risk-free rate with the term structure just uses a flat forward, which means just constant rate the whole time, like in Black-Scholes. Similarly for dividend, flat forward, constant value for the entire term structure. Volatility term structure, we did black constant vol, means constant volatility for the entire term structure. Later videos will show to make it more general. We have the Black-Scholes-Merton process. I wrote expiration date here. So I don't know why I put this. Let's get this. This is a European exercise. Europe in the European option, and we set the pricing engine to the analytical pricing engine. We get the price by doing .net present value, and now we compare the two. We'll compare the ChatGPT version and the regular version. So here it has the QuantLib and ChatGPT. They're very similar. Slight numerical differences at the end. That's for call options. Maybe we'll let's just do a random put value. Very similar. Anyways, this is just an introduction to QuantLib. Didn't have time to do a interactive related volatility model, but this will be very important in the future if you do trade options and you need to know things. Let's say I'll give you an example. Let's say I'm trading call options and I want to know if I can make this trade or it's too asking for too much. So I want to know if the stock price if the option price can go up X amount within a certain time. I really need to calculate that in a good way or get a good estimate for that. And it's very good to have like a few different models to calculate the expected option price change when the stock changes, and that sort of thing, in a certain amount of time. And it's very important because that could cost you a lot if you think you can do this trade, but you're like overshooting or whatever. Like, anyways, I hope you enjoyed the video. If you're new, please like and subscribe. And thank you. Sorry this was a day later than I promised, but it's still Thursday for people who live in like California, so I guess you could give me some partial credit. Okay. Thank you guys. Have a good weekend.